Hello everyone, welcome to new class. Today's class is about PN junction diode. If a piece of intrinsic silicon is doped so that half is N type and the other half is P type, a PN junction forms at the boundary between the two regions and a diode is created. So this is called a PN junction diode because half is doped with the P type and half is doped with the N type materials. And here the schematic symbol of PN junction diode is like this. So this is P side and this is N side. So this is the schematic symbol of PN junction diode. And at the instant of the PN junction formation, the free electrons near the junction in the N region begin to diffuse across the junction into the P region, where they combine with the holes near the junction. So these electrons combine with the holes near the junction, and when the PN junction is formed, the N region loses free electrons as they diffuse across the junction, and this creates a layer of positive charges near the junction. So here there will be a positive charge due to the loss of the electrons. And as the electrons move across the junction, the P region loses holes as the electrons and holes combine here. So here the electrons and holes combine, and this creates a layer of negative charges near the junction. And these two layers of positive and negative charges form the depletion region. So this is called the depletion region. Depletion region. The positive and negative charges at the near the junction makes the depletion region. And the term depletion refers to the fact that the region near the PN junction is depleted of charge carriers. Charge carriers means electrons and holes due to diffusion across the junction. And the small region in the vicinity of the junction which has been depleted to mobile charges and has only immobile ions is called the depletion region or transition region, also called transition region or space charge region. So these are immobile ions. So this is negative ion and this is positive ion. So in this way PN junction diode is formed. So half of the intrinsic silicon is doped with the P type and half is doped with the N type material. Next is barrier potential. So here in the depletion region there are many positive charges and many negative charges on opposite sides of the PN junction, and the forces between the opposite charges form a field of forces called electric field. So here there will be a force called electric field, and this electric field is barrier to the free electrons in the N region, and energy must be expanded to move an electron through the electric field. That is, external energy must be applied to get the electrons to move across the barrier of the electric field in the depletion region. And the potential difference of the electric field across the depletion region is the amount of voltage required to move electrons through the electric field, and this potential difference is called barrier potential. So the potential difference required to move the electrons through the electric field is called the barrier potential, and it is expressed in volts. And the typical barrier potential is 0.7 volt for silicon and 0.3 volt for germanium. And here this is the internal potential barrier. So this is internal potential barrier, and the external force or external voltage can be given forward bias or reverse bias. So in the case of forward bias, it will be like this, that is, this is anode and this is cathode. So here when positive is connected to this P region and negative is connected to the N region, it is called forward bias. And when this negative of the external voltage source is connected to the P side and positive of the external source is connected to the negative N region, then it is called reverse bias. So in this way external source can be applied, and when forward bias voltage is applied, it reduces the barrier potential. That is, it reduces the barrier potential, allowing current to flow through the diode. And in reverse bias, it increases the barrier potential, preventing significant current flow. So that is about the PN junction diode and barrier potential. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.